So today we will do the next theorem related to the outer measure. With the example, we were doing the examples of the sets who have the outer measure 0, in which we have done the set of natural numbers, set of integers, set of rational numbers, set of all algebraic numbers. So they have the measure 0, and the most important is that the all sets were countable. Now we will now prove a set which is uncountable, but it has a measure 0. Next example is, we can say that given example of a uncountable set. Give an example of an uncountable set having the measure 0. ठीक है जी? So come to its proof now. Or in other words, another statement और करके prove करें, लिखेंगे show that outer measure of Cantor set is 0. Of Cantor set is 0. Right? Show that the outer measure of the Cantor set is 0. Because this is the uncountable set whose measure is 0. This is an example of an uncountable set. Right? So come to its proof. First of all, we know how to denote the Cantor set. We do denote the Cantor set by C. C is equal to intersection and running from 1 to infinity, Fn, right? What is F naught? F naught is a total interval, closed interval 0 to 1. What is F1? F1 is equal to 0 to 1 by 3 union 2 by 3 to 1, right? Then, again, next is F2. F2, we know how to write the, क्योंकि हम इसको 3 पार्ट्स में, इक्वल पार्ट्स में हर बारी डिवाइड करते हैं, and we always leave the middle open interval. So this is 2 by 9 and here is 1 by 3 union 2 by 3, 7 by 9 union 8 by 9 and 1. Right? So this will go on. This is open interval, but I am writing here 8 by 9 to the closed interval, right? So now in general, Fn, every Fn is the union of 2 raised to power n disjoint closed intervals, each of length 1 by 3 raised to power n. ठीक है जी? सपोज करिए हमारे पास पहला इंटरवल था F1 में कितने इंटरवल आ रहे हैं? 0 to 1 by 3, राइट? यूनियन 2 by 3 to 1. तो इसमें कितने क्लोज इंटरवल है? 2 क्लोज इंटरवल है. लेंथ कितनी है? 1 by 3. 1 by 3, 1 minus 2 by 3, that is 1 by 3. अगले में 4 इंटरवल्स है. लेंथ कितनी हो जाएगी? 1 by 3 स्क्वायर. इसी तरह ये चलता जाएगा. It implies, therefore, जो outer measure है Fn का, हर Fn का, वो 2 raised to power n into its length. It is less than, or we can express as the outer measure of Fn will be less than or equal to 2 raised to power, हर एक में कितने intervals पड़े हैं? 2 raised to power n into 1 by 3 raised to power. उसको उसके multiply कर दिया. So that is m star Fn is less than or equal to 2 by 3 whole raised to power n. It implies C is equal to, now C, what is C? C is the intersection and running from 1 to infinity, Fn. It implies C is C. This is C and this is sign of contained. C is contained in N for Fn for all. कि intersection में आ रहा है, मतलब C जो है हर एक Fn में आ रहा है. So by the property of outer measure, M star C is less than or equal to M star Fn for all n belongs to n, right? And we have the number one. Number one क्या कहता था? Number one means what was M star of Fn? This is less than or equal to 2 by 3 raised to power n. It implies the outer measure of the set is less than or equal to 2 by 3 raised to power n. N belongs to n. n एक natural number है and we know that 2 by 3 raised to power n is tending to 0 as n tends to infinity क्योंकि 2 by 3 quantity जो है वो less than 1 है. It implies m star c is less than or equal to 0 but m star c is always greater than or equal to 0. It implies m star c is equal to 0. So therefore, Cantor set is an uncountable set having the measure c. So this is all about the examples of countable sets whose measure is 0 and uncountable set whose measure is 0.